What's up, everybody? In this video, we're going to be covering USACO's 2019 Open Contest at the silver level, problem number 1, left out. Farmer John is attempting to take a photograph of his herd of cows. From past experience, he knows this particular endeavor never usually ends well. This time, Farmer John has purchased an expensive drone in order to take an aerial photo. To make the photo look as good as possible, he wants his cows all to be facing the same direction when the photo is taken. The cows are currently arranged in an n by n grid, which is n between 2 and 1,000. So it'll be a perfect square. And at most, it would be 1,000 by 1,000, which is 1 million locations. Just for record, 1 million is 10 to the 6th. So that's the number of cows that there are total in the field when you consider it being n by n. Inside a fenced-in square pasture, for example, these are then cows facing right or left. So I've got like a cow facing right, a cow facing left, a cow facing right, 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 left, 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 right. Here, R means the cow is facing to the right, and L means the cow is facing to the left. Since the cows are packed together, Farmer John cannot walk up to an individual cow to make it turn around. All he can do is shout at any row or column of cows to turn around, causing L's to change to R's and R's to change to L's. Within the row or the column in question. Anytime I see something like that where there's only 2 states, I'm usually thinking I'm probably going to use a Boolean for this. So most likely the way I would want to represent this is going to be a 2-dimensional array of Booleans. Farmer John can yell at as many rows or columns as he wants, even at the same row or column more than once. As expected, Farmer John observes that he is unable to make his cows all face one common direction. The best he can do is get all but one of the cows to face the same direction. Please determine the identity of such a cow. So we are guaranteed that there's going to be one cow that cannot be made to face the same direction as the rest of the cows. If you've ever experienced, if you've worked with Rubik's Cubes or done those sliding tile puzzles where there's like one tile missing and then you have numbers on them. If you take these apart, whether this or the Rubik's Cube, and you rearrange certain things, it's possible to create a situation where the problem has no solution. There's a lot of reasons for this, but in general, the way a lot of puzzles work is when you're changing something, you're changing multiple things. And if you have to change an even number of things and an odd number of them are out of place, that means that there's no way to get them back to the way they're supposed to be. So that's what's going to happen here. This is going to be one of those puzzles where in the end, you'll find out that it must have been rearranged because the starting state, the perfect starting state of solution cannot be reached. Okay, so our input format is coming from a file called leftout.in. It says the first line contains n, which is the size of the field. Remember, n by n, it's a square. The next n lines describe rows 1 through n in the grid of cows, each containing a string of length n. Right, so here we've got an integer, and then on each one of these, we're going to have a line of characters that we'll have to read from the file. The number of lines there will be defined by n, and the length of the strings also will be defined by n. Your output format will go to leftout.out. It's another file writer. Print the row and column index of a cow such that if that cow were flipped, Farmer John could make all his cows face the same direction. So basically, we're finding the one that can't be solved. If no such cow exists, print -1. If multiple such cows exist, print the one with the smallest row index. Okay, so it is possible to have more than one cow out of place. Or if multiple such cows have the same smallest row index, print the one with the smallest column index. Okay, so if we have more than one cow that's out of place, we'll sort by row first and then by column, and then print the one with the smallest index. Also, in any situation where we have 2 flipped, if there's a way to flip it such that only one is flipped, we're going to want to make whatever that flip is. So for example, if you had like right, left, left, and then the rest of this was, let's do left, 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 something like this. No, that's a bad example. Let me start here. It'd be right, left, left, and then right, 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 right. So if you had something like this, where you have 2 cows that are out of place here and here, we wouldn't want to report this cow. What you would actually do is flip this column so that instead of having 2 that are facing left, we would have only 1 facing left. You'd have a left one here and then right, right. And then you'd report this one as the odd one out. So essentially what you're trying to do is you're trying to get as few cows as possible facing the wrong way. And once you get to what you consider a solved state, whichever one's on the top left, doing up first and then left if there's multiple on the same row. All right, let's look at our sample example here. R, L, R. Instead of writing R's and L's, I'm going to do a circle for R, and I'll do a circle with a line for it through it for L. So this would be all R's, for example. I'm going to say this one's L. This is going to be easier to draw with a pen. Left, left, and left. So I have then, this is right, left, right, 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 left, and then left, left, right. And actually, it turns out, since it doesn't matter if they're all facing right or if they're all facing left, and since if they were all facing left, you could just flip every row and then they would all be facing right. And since we don't have to specifically say how many turns it takes or what the order is, we only have to say the cows that are out of place. You can try to solve for them all to be true or for them all to be false. It doesn't really matter. So whether or not the circle represents a true or a false or a right or a left, that's all fully interchangeable. Okay, so just kind of looking at this, we're trying to get it, let's try and get it so they're all circles. So for example, I could flip this row right here, which would mean this one would lose the line, this would lose the line, and then this one would gain it. I could then flip this right here, which would mean this one would lose, this one would lose, and this one would gain. Then I could flip the top row, so it would be gain, and then lose, lose, and then I'm left with one cow. Now it's important to note, they said the sample output is 1, 1. Let's read why. In the example above, the cow in row 1, column 1, the upper left corner, they're calling this row 1, column 1, the upper left corner, is the offending cow, since Farmer John can shout at rows 2 and column 3 to make all other cows face left with just one cow facing right. Shout at row 2, column 3. Let's back that up because I actually used a different solution, but I came up with the same answer. What I'm pointing out here, though, is that they're doing a 1 indexing. So this 1, 1 is the top row in the leftmost column instead of 0, 0, and then the bottom right would be 3, 3 in this example. But they said Farmer John can shout at row 2, which would be this row right here. I would go flip, flip, and then back, and column 3, which is this one right here, flip, flip, flip. And see, so I solved for all circles, they solved for all slashes. And again, remember I mentioned that it doesn't matter which one you do. This still is the offending cow in this example. In order to create the solution that I found then, if you were to go through and then flip every single row, you would have this one with the line and then that, and we would come to the same conclusion that it's the same cow that's out of place. So in order to approach this problem, I would recommend, as I usually do, getting a pencil and paper and drawing out as many examples of this as you can. One of the ways that you can kind of start to plan these out is to start with a blank canvas. Start with them all facing the same way. So we'll go flip, 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 flip. Okay, and then start just flipping rows and columns and kind of get a feel for how the mechanics of this problem work. For example, if I wanted to try and create something that's scrambled, I could flip this and I would go flip, flip, flip. I could flip that column, which would go flip, flip, and then unflip the top. I could flip the middle, so I would have flip, flip, and this one would be unflipped. I could flip the right side here, and then flip, flip, and flip. Okay, then I've left arrows where I did the flips. Now, let's unflip them in a completely different order and see what happens. I don't even remember which one I did first, but it wasn't this one. So let's unflip this one. So I'll go flip, flip, flip. Let's unflip this one. So I'll go flip and then unflip, unflip. We're going to unflip this one up here on the top left, which is going to go unflip, unflip, and flip. Oops, that one didn't erase. And then finally unflipping this last one, and we're back to our starting condition. So it looks like the order doesn't matter. And that makes sense if you think about it, because if I flip this row, these all get flipped one time. If I flipped this column, then that would get flipped a second time, and these would get flipped once. The number of times that something's been flipped is going to be the same if I undo them in any order. Because if I were to then flip this one a second time, if I were to remove this flip and flip it back, I'll lose one of the flips from here and these two. And if I were to undo this flip here, I'm going to lose one of the flips from here and these two. And this is going to unflip twice on the top left, regardless of which order I do it in. So that's your first observation, is realizing that the order actually doesn't matter. It's just which ones get flipped. The second observation is that in order to flip a column, I have to flip the thing on the top. And that's just kind of a given. Obviously, I have to flip all of them, but this one in particular, this one has to be flipped. If I have to flip this one, If I have to flip this row, then I have to flip this one. And what that means is that by looking at the edge here, by looking at this piece, you will know, generally speaking, how many times this column has been flipped. Because if I flipped it once, I would have a line through it. And I flipped it twice, I wouldn't. And if I flipped it twice, it would be the same as if I never flipped it at all. So in every single one of these rows and columns, essentially, we have a true or false on whether or not that particular row or that particular column has ever been flipped at all. Has this column ever been flipped? If it's been flipped, this will be a slash. Has this column ever been flipped? If so, then this will be a slash. If one of those is a slash, then we know the whole entire sequence has to be a slash. If this one had been flipped, that one would be a slash. Now the ones down here in the field, these guys, they're just going to respond to what's happening as the edges are getting flipped. But by looking just at this and saying, okay, if I want to solve for all slashes, if I want to make everything a slash, or if I want to make everything a circle, then I can look and see where things have been flipped just by looking at the outside. So for example, this one's been flipped, so I can unflip it, which would cause these to flip. And then I can see that both of these have been flipped. And I also can just tell by looking that if I were to unflip both of those to fix them, it would cause the rest of the board to be flipped. Okay, so the premise of this, though, is that one of them is wrong to start with. So let's go ahead and make one of them wrong. Make this one wrong to start with. And then we'll just scramble up the board a bit. So I'm going to flip this one, flip, flip. I'm going to flip this one, flip. And then these two will unflip. And I'm going to flip the bottom one. And I'll go flip, flip, flip. Okay. So looking at this then, we're going to unflip them again, just in a random order. Actually, let's try to flip them all to slashes and see if we get the same one incorrect at the end. Let's just backtrack and remember which one we marked. The one on the bottom here is the one that's the incorrect one, the bottom center. I'll mark that in green here so we don't forget. It's up to here. Okay, so this was the one that was, this one was the one that was originally wrong. Okay, so we're going to try and make them all have slashes and just see what happens. I'm going to flip this one since they all started as circles. I'm going to flip this top row. I'm going to go slash, slash, and then this becomes a circle. And then I'm going to flip this column, and it'll be slash, slash, and this one's fixed. And then once again, I have an odd one out. It's the same one. So it didn't matter whether I went for all slashes or if I went for all circles, I still ended up with identifying the same cow. So there are a couple situations that are going to occur, but your first step is going to be to go around the outside and fix all of the ones that are on the outside border. Once these are fixed, depending on what the board looks like, that's how you can decide which cow was right or wrong at the beginning. So for example, let's look at this one more time and kind of play with this. I'm going to make this one be wrong. I'm going to flip this one and this one. That's going to go flip, flip, unflip, and then this one will go unflip, and then flip, flip. We're then trying to identify where the problem is. By working our way around the outside, we can see that one and that one have been flipped. So if I work my way around the outside, heading in the counterclockwise, it doesn't actually matter which direction we do, but if I'm going to do it in the counterclockwise direction, so starting from this top one, I see that this one's flipped. I conclude that this column must have been flipped, so I flip it back. Work my way across. That's a circle. That's a circle. This one's got a slash, which means this row must have been flipped, so I'll unflip it. And then they're all fixed, and what I'm left with is this bottom one being out of place. Okay, so the next step is trying to figure out what are some odd situations that might occur. For example, what would happen if the one that was out of place was one of the ones on the edge? So certainly then, if I were to go back and flip that, that would be a problem. So let's flip this row, or sorry, this column here. We'll flip the bottom row, flip, flip, unflip. And then we're going to attempt to solve it for all slashes again. I want to make slashes through everything. I'm just mixing it up to show that the order doesn't matter. Okay, working our way around the outside. This is the first one that's off, so I'm going to put a slash through that. We're trying to make slashes. This one is okay. This one is off, so I'm going to flip that, flip the line, and then out, out. Working my way across. This one is a circle, so I'm going to flip that one. It's going to go unflip, unflip, and then I'm going to flip this one, which is going to go flip, flip, flip. Now, looking at the final board, I can see that I've got two circles here. Remember, we want to try and minimize the number of circles. When I see something like that, that indicates to me if I've got an entire column or an entire row that's bad, but the outside is flipped, and what that tells me is that it must have been this thing that was wrong in the first place. Because if one of these, we'll call these like the row leader, if the row leader is fixed, but then their entire row is wrong, then that's the row leader's fault, which would mean we would need to flip the row leader back and then flip these two. And then that would solve the problem. Once again, then with this one being the one that was wrong in the beginning. So if we have one of the row leaders, which include this one, this one, this one, and this one being wrong initially, then what's going to happen is eventually when we try to fix it, its entire row will go bad, or its entire column will go bad. So at the end, after running through and fixing, if we've got an entire row bad, that means that the row leader is the one that's at fault. Last special situation to watch out for. What would happen if the one in the corner is at fault? The one in the corner is a special situation, because if this one is wrong to start with, then as we go through, what's going to happen is fixing that is going to mess up all of the row leaders. So I clear that one, but then this one's going to flip and this one's going to flip. As I then might work my way around trying to make O's in this case, this one's got a slash, so I'm going to unflip it. That's going to mess up his entire row. And then this one's going to unflip, and that's going to mix up her entire row. When I get to the end, if all of the leaders are correct, but then all of the cows in this group, if every single one of them is wrong, that means that the drum major or whatever, the main leader in the front here was wrong. And the reason why that happened is because if that one is the only one that's wrong to start with, I'll just rerun that again. If that one's the only one wrong to start with, then fixing it will require you to mess up either all of the column leaders, because there could be more than two, or all of the row leaders in order to fix the corner, which then means that that error is going to get carried out to the entire field. And then you'll end up with the whole entire field being backwards. Okay, so just to kind of review the algorithm, what we're going to do is we're going to take our initial load here. I would recommend a Boolean array. It doesn't really matter how you want to do it. If you want to use a character array, I'm sure that's fine. It won't change the time complexity. It just would use a little bit more memory. Once we get our initial load, which is guaranteed to be a square, we mark whichever ones are false as a starting position. We then work our way around the outside. Anytime we hit one that is false, if we decide we're going to make it all true or vice versa, we flip that entire row, making sure that you handle this corner here. It doesn't matter if you flip the entire column or the entire row, whichever side. Actually, if you're coming at it this way, it does matter. If you're coming at it this way, you wouldn't want to flip your entire top row, because then you would have to go back and flip all these guys again. So the sensible way to do it, if you've got one that's flipped in the top corner that you have to flip, is treat it as soon as you get it, treat it like a like you're flipping all of that entire column. If you're doing columns first, when you hit the corner and it's wrong, treat it as a column, not as a row. Otherwise, you'll mess these ones up. Once you get all the way down to the bottom, look at the board. If you've got, as you work your way around the outside here, if you find one that's wrong, check to see, is its entire column wrong? If its entire column is wrong, or if the entire row is wrong, that means that one of the row leaders was wrong in the beginning. If it turns out that the entire row and the entire column is wrong, that indicates that all of them were wrong, most likely, which would mean that the top corner was wrong initially, and that caused the whole entire field to be wrong. If you don't find anything around the outside that indicates that it's wrong, if all the outside is correct, then you still have to go through the entire middle and see if there's a single cow in the middle that's incorrect, because there's got to be a cow that's wrong somewhere. The amount of work that it takes to do this, we discussed earlier, the largest possible board is 1,000 by 1,000, which is going to be 10 to the 6th. 10 to the 6th, if you have to go through that and check every single cow, you will check 10 to the 6th cows, and 10 to the 6th is well within your runtime capacity. In addition, as you're going through flipping columns, you might have to flip up to 1 million cows, which would just be 2 times 10 to the 6th. And again, 2 times 10 to the 6th is a very reasonable number that should run very quickly. Alrighty, I think that's pretty much all you need in order to solve the problem. So best of luck. And just remember, by the way, the top left corner is 1, 1. So you'll have to figure out how or where you're going to add or subtract 1 to deal with that. Good luck coding it, and I'll talk to you in the next video.